Welcome to BKW Physics. I'm Mr. McConley. Today we're going to do an example where we have a truck on a ramp. And the situation is going to be that this truck is parked on the ramp and you're not holding the brakes and the truck is going to roll away. And I want to know what's the acceleration of the truck as it rolls away, assuming no friction, because we're not going to have the brakes on and we're just going to assume there's no friction, just to make it a simpler problem. Nah, I changed my mind. We can add some friction. And I think I'm going to have, I just changed it, it's fine, I can still work it out. We're going to have the friction of this truck be 200 newtons. Okay? That'll be easy enough to add to my problem here. And we know that the weight of the truck is 820 newtons. By the way, that's like a really light truck. It's just a dumb example. I don't know why I use that number, but anyway, we keep going. So what does the picture look like? Well, this particular incline, hill, if you will, ramp, hill, whatever you want it to be, is going to be a 40-degree incline. Steep. Road-wise, that's steep. So let's draw our picture. It would look something like this. If this is flat horizontal, this might be something like a 40-degree angle. Our truck might be something like this. We got some nice rims on. Here's some gas. We gotta have a windshield. Crew cab. We got some flats. Those extra thick fenders. I gotta have one of those deer guard things in there. Anyway, you can go as long as you want with your picture. I don't really want to go into too much detail, but it might be your brother's truck. Okay? Just saying. The force of gravity is pointing straight down. It's 820 newtons. What other forces can we label on this picture? Force of friction, because I did add it in now. So the force of friction is which way from the center of the truck?
That way.
To the right and up the hill. Parallel to the hill, upwards. What other forces do we have? Back rowers.
Normal force.
Normal force. Now normal force is tricky on the hill. You don't want to just point it straight up. It's not like that. It's straight up from the flatness of the hill, or in other words, you gotta go straight up perpendicular to the hill. So it actually ends up looking like a little hill now. What are the other two we got here? That's parallel and that's perpendicular, and they're actually parts of the weight. So the way I try to always figure out how to draw them correctly is I find something that's square and pretty big. I don't really have anything big enough. And I say, okay, if I'm starting from the end there, and eventually it's going to have to be about that big. See how I kind of figured that out? Okay, because I want it to meet at a 90 degree. And I want this one to be parallel to the hill. This is, of course, parallel. And I want this one to be perpendicular to the hill. And end up going like that. Now, if I'm interested in finding the acceleration of the truck, what force am I really interested in finding? Yeah, I mean, I agree with you. The fourth parallel is the one that's going to pull it down the hill. But there's one fighting it, the friction force. So I'm not really interested in the normal or the gravity so much. But what I'm interested in, I'm definitely interested in the force parallel, right here, this one. And I'm interested in this one, which I already know is 200, but I have to kind of subtract it from how much it's going to push me down the hill, right? Or pull me down the hill. So, yeah, I agree with you. If we find the force parallel, I think we'll be all set. So let's go ahead and do that. We've got a right triangle. We know that if this is 40, we know this angle down here is also 40. And so we're going to use opposite over hypotenuse to be the sine. Sine theta is opposite over hypotenuse. Sine of 40 degrees is the parallel one over 820 newtons. therefore going to turn out to be 527. I got the same number. Good. So we got 527 pulling us down the hill. Now, in a way, right now, I'm kind of thinking I need the net force, but I need the net force only parallel to the hill. You know what I mean? You don't care about the up and down stuff. So I only need the net force parallel to the hill, so I really need to say, what's the parallel one and what's the friction one when I add them or combine them. So I got 527 pulling me down the hill. How much is fighting me the other way? 200. And you got to make sure that's negative because it's the other direction. So what am I left with? 327 newtons that are responsible for pulling me down the hill. Now let's back up. What were we trying to find again? What's our equation for acceleration? Yeah. That's acceleration equals the net force. So, little side problem. What is the mass of the vehicle? Because the weight is 820, remember? We can't just say that the mass is 820. It's not. The mass is something different. It's the weight divided by gravity. It's 820 divided by 9.81, or 83.6, to be exacting. So now we know the mass. That's the little side problem we had to think through. And we say 83.6 kilograms is equal, or no, times the acceleration is equal to 327. So then we find that the acceleration is a meager 3.9 meter seconds. So if we park the truck there, we don't touch the brakes, it's got 200 newtons of friction, thing rolls away, it's going to accelerate at 3.9, which is not incredibly fast, but it's going to start rolling away. And that's what we have found. So this is an example of how you can do something on a ramp, use forces to find acceleration.